Okay, so we start the class. So I graded quiz, and most of you did better in quiz 2 than quiz 1. The solutions are available on the website, and yeah, actually the two of you got the right answer, but I wonder if the process is complete. So I think the Brennan and the Sydney. So I couldn't really understand how you calculated it. So let me know if you made a shortcut to calculate the interest earned on the force of interest. So basically, you have to integrate. Maybe I can share the screen. Yeah. So basically, if force of interest is given, then you have to integrate. We have to integrate this from the time period, the starting period to the end period. So if we integrate this becomes log of t plus 15. So we plug in 4 and 0, then this becomes 19 over 15. Yeah, and the other one is just the compounding interest rate. So 8% compounded quarterly, nominal rate of 8% compounded quarterly. So that is 2% for each quarter. So we have 16 quarters in 4 years. So the 1 plus 0.08 over 4 to the power 16. Yep. So usually you don't really care too much about the rounding errors. But if your answer is not really close to 1734, then maybe you have to be a little bit more careful for rounding. Okay, so this class is the theory of interest. So I would like you to be interested in the financial market, the fixed income products, especially. So maybe you have heard news that the Federal Reserve will increase the interest rate this year. So what is the best source to see the interest rate in the future? For example, 1 year from now. Do you have any suggestion or?
The financial aid website.
Financial, sorry?
FAFSA. FAFSA.
Uh-huh.
FAFSA.
FAFSA?
Yeah.
Any others? Maybe different people have different opinions. So my suggestion is to see this website. The CME is the Chicago Mercantile Exchange. This is the Financial Futures Exchange. And based on the financial derivative prices, we can calculate the probability of interest in the future. For example, the December, maybe this year, almost 1 year from now. So we can see this is the forecast based on the financial derivative prices. So this means that so currently the interest rate is between 0 to 25 basis point. So basis point means the 100th point. So 0% to 0.25%. But in December, basically the maybe median and also mode is between 100 to 125 basis points. So that means that we will have probably 4 interest hike of maybe 0.25% each. So I think that this is most accurate and the most updated forecast. So you don't really have to listen to the Wall Street Journal or New York Times or any economists. So this is most accurate and the most up-to-date forecast for US interest. For example, March, probably we will have one interest rate hike. So 91.6% of, probability of 91.6% that we have the 0.25% interest rate increase. Maybe 5.4% that we have a 0.5% increase. And yeah, and so on. And these dates, January 26th, that is today actually, and March 16th and May 4th. So these are the dates for FOMC. So sorry, the Federal Open Market Committee date. So after today's meeting, so we have a release, and possibly we have some changes in monetary policy. Okay, so do you have any questions about quizzes or this website?
I do.
Okay. Yeah.
So about the quizzes, how many, so for the interest rate, should I keep it exact or should I round it to a certain number of decimal places?
You don't really have to round. So I don't care about rounding. So yeah, so you can just write the answer you got. Yeah, okay. And at least, but the interest rate, at least I suggest the answer to the basis points, like the 1.23%.
Okay.
Yep. Okay, so now we have chapter 3. So we go to chapter 3 today. Maybe before that, maybe we have to finish one slide in chapter 2. Okay, so I have to share screen. Okay, so just I want to finish up the last slide of chapter 2. So we have solved the problem for unknown time. So we have the basically two people that who have the same amount at time 0. And the one person that withdrew $10 at time 6, and the $30 at time 9, and the $40 at time 12. Then the fund has depleted. So then the another person have the X dollar at the beginning, and they have the same interest rates, and he or she withdrew money at time T, the $80 at time T. Then the fund becomes zero balance. So what is T? And last time that we compare the two cash flow at T is equal to 0, then the second person, basically, their X should be 80 times the V to the T's power. So I would say this is X. And the first person, actually, this X should be 10 times the V to the power 6 plus 30 times V to the power 9 plus 40 times the V to the power 12. So if we solve this for T, then T gets this, and 10.02 years. And okay, so this is a complete answer, but also if you don't have a time to evaluate this accurately, then we have a trick to calculate it in a short time. So that is, okay, so we just take the weighted average of these times, so 6 and the 9 and 12. So we have $10, $30, and the $40. So we take the weighted average of 6, 9, and 12 with weight 10, 30, and 40. So weighted average time of withdrawal is, so okay, so at first weight is the 10 and 30 and 40, and we multiply by time 6 and 9 and 12. Then this becomes 10.125. So this is very close to the true answer, 10.02. We have the error of 0.1 year. So this is called the method of equated time. Yeah, so this is basically the weighted average of times of withdrawal. Yeah, and okay, so this number is actually larger than the true answer, but this is actually always true. So T tilde is always larger than T if I is equal to positive number. So proof idea, we use proof idea. We don't prove it. It's not super difficult, but the proof idea is to use the v to the power t function is a convex function. Convex function. I mean, convex function of t. So the v to the power t, v is a constant which is less than 1. So the v to the power t is like this. So this is t, and this is v to the power t, and this is convex or concave upward. So using this, you can prove that t tilde is always larger than t. Okay, so do you have any questions? So you cannot get the exact answer by t tilde, but if you just want to roughly get the idea of the answer, you can do this. Okay, so now chapter 3. Yeah. Yeah, so in chapter 3, that we define the several notation in fixed income products. So the very special notations in this financial mathematics. Maybe it makes an entry barrier to actuarial world. So always the people that make entry barrier to keep their jobs. So it has some negative side. And probably these symbols are useful in old days before the people, all people use computers, computer programming. So we define the annuity immediate and annuity due in this section. So these are the specific cash flow. So compared to chapter 2, the chapter 3 is more specific about what type of cash flow we deal with. So in some sense, it's easier, but there are several things to memorize, I mean, notations. So first we start with an example. So assume that I is equal to 6%. The usually I is constant throughout this chapter. So okay, so think about a cash flow. So we have maybe the 50 years. 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 50 years of cash flow. But so only cash flow every 5 years. Suppose that you receive $100 at time 10, and the 100 at 15, 20, 25, up to 50. So we want to calculate the present value of this cash flow. So in this section, basically we deal with this kind of the repeated payments of the same amount with equal interval. And V is equal to 1 over 1.06. So this is 0.9434. So maybe again that I ask you to guess the PV. What is the PV? Total payment amount is what? The $100 times 1, 2, 3, 4, 5, 6, 7, 8, 9. So $900. What is the present value?
700.
700. Others?
750.
750. Any others? Maybe two more.
720.
720.
730.
730. Who said 730? Sorry, who said the 730? Hello?
Kenneth Graham. Yep. I did.
Kenneth?
Yeah.
And 700 is whose one?
That was me. Garrett Clay.
Garrett Clay, sorry. Okay, so okay, we start. So maybe I make a guess first. So we have the $900. So and the center one is this one, right? So about 30 years of interest we will get. So 30 years of 6% interest. That is 30 times 6, so 180. So basically $1 becomes 108. Sorry, 100. Sorry. 180%. So $1 becomes $2.8 after 30 years, right? So my guess is that we divide 900 by 2.8. So probably $330 or something. I don't know. Yeah, so I think that all of these answers are not really close, I guess. Okay, so we start. And PV. So the way to calculate this is always we evaluate at time 0. So this $100 becomes 100 times
V2. 100
V10.
V2.
Yeah, yeah. So
100 V10. Yeah. There.
V10, right? And the 100 times the V15 and the up to 100 times V50 and equals 100 times the V10th and the 1 plus the V to the 5th power, V to the 10th power up to V to the 45th power. So this is 100 times the V10th times we have summation, so geometric sequence. So 1 minus V to the power 50 over 1 minus V5. So then you can plug in numbers 3 times, then you get 200, actually even smaller than 300, 274 times 1/8. I think all of the answers are not close, but okay, maybe the 700 is the closest. So Garrett Clay will get 2 points. Maybe I should give a little more time to you, make you to think about it. Okay, so 274, and what is accumulated value? What is the accumulated value at 50? So that is the PV times.
Would be the other way around, going from 50.
Yeah. PV times the interest to the 50th power. So every year we multiply 1.06. So that is, and yeah, I don't know what's the number. 1.06 times 50 times 274.18. So 50.438. So 5,050.
Don't we have to change the interest rate because we're doing it every 5 years?
Yeah, of course, we can multiply 1.06 to the 5th power to the 10th power, but yeah, that's the same thing.
Okay.
Yeah, so yeah, but we can certainly do that. Yeah, 1.06 to the power 5th. So yeah, you can define j as 1.06 to the 5th power minus 1. Then everything is we can make the time unit as 5 years. Yes, you can do that. Yeah, maybe that's simpler. Yeah. Especially after we studied Annuity Due and Annuity Immediate, it's much easier to go, this way. Yeah. So always the accumulated value is equal to present value times 1 plus I to the power capital T if AV is evaluated at T is equal to capital T and PV is evaluated at T is equal to 0. So sometimes you are asked the present value, sometimes accumulated value, but basically those are the same question. As long as you adjust this term, I mean this factor, then we can calculate, we can translate from PV to AV or AV to PV. Any questions? Okay, so next we define annuity immediate. So annuity immediate is cash flow, which is represented by the n years of $1. I mean $1 a year for n years. So that means if we have 0, 1, 2, 3 up to n, then we have $1 every year for n years. So this is called annuity immediate. So annuity immediate is this cash flow. So interest rate is fixed, annual effective rate. Yeah, and so we define the symbol a right angle n like this, a right angle n. So this is the present value of this cash flow. So the definition of a right angle n. A right angle n is defined by the present value of annuity immediate. Maybe I have to write a right angle n I because it depends on I. present value, of course, depends on I. So a right angle n I. But I is often omitted if it's clear. So I is given, if the I is given in the first sentence of the entire problem, then we omit I. And what is this PV? So this PV is the present value of this cash flow. So, okay, so this $1 is worth V dollars, and this $1 is worth the V squared dollar at time 0. So that means the present value is V plus, okay, so V plus the V square plus the V cube plus up to the V to the nth power. So that means that this is V times 1 minus Vn over 1 minus V. Okay, so yeah, that this is again the geometric sequence. Yeah, so yeah, we can even simplify this into this, the 1 minus V over V. And remember that the V is equal to 1 over 1 plus I. So 1 minus V over V is equal to 1 over 1 plus I here, and here 1 minus 1 over 1 plus I. So we multiply 1 plus I on both sides, then actually 1 plus I minus 1. So this is I. So this becomes I. So that means 1 minus V to the power n over I. So this is the formula for a right angle n. Yeah. Or of course you can write this with I, 1 minus 1 plus I to the power negative n over I. Because V is 1 over 1 plus I. Yep. Yeah, so I wanted to say this one here. Yeah. Right. Yeah, so, and we write sometimes the A right angle NI. Yeah, so right. To be explicit on interest rate. Okay, so this is AN, and next we want to define another symbol, which is the accumulated value of this cash flow. So basically, this accumulates the n years of interest. So just the S right angle n is the A right angle n times 1 to the, sorry, the 1 plus I to the power n. So usually I put in a parenthesis the so that the cash inflow and cash outflow matches. Okay, so if I write the this and this, it's confusing. So I just put one in parenthesis. So either S right angle n or S right angle n in this, time diagram. So the definition of the S right angle n is the accumulated value of annuity immediate for n years. Annuity immediate. So this is equal to 1 plus I to the nth power times a right angle n. So this is equal to 1 plus I nth power and times the 1 minus the b to the nth power over I. So so this becomes, okay, so v to the power n is the 1 plus I to the power negative n. So maybe it's better to put in this way and it's clearer. Then this becomes 1 plus I to the n minus 1 over I. It may look even simpler. So S sub n, S right angle n is equal to this one. And we say this annuity as annuity immediate because this, the lump sum payment of S right angle n is immediately after the last payment. It's not very easy to interpret this, but the original meaning of annuity immediate is this. Okay, so now that we have defined S right angle n and the A right angle n, so n and I are given that we can calculate this immediately, and our calculator, the BA2 plus, has the function to calculate this at once. Any questions? Have you ever seen A right angle n or S right angle n?
No.
No, right? So I have never seen it before I see the financial math textbook. So it's very special symbol, and the meaning isn't really, difficult. But if you see at the first time, then it looks very difficult. But actually, it's very simple notation. And next one, the definition of annuity due. So this is almost the same. Maybe we don't even need this notation, but they have many notations. So annuity due only differ by 1 year. So cash flow start at time 0 and the end at time n minus 1. And the present value of this is called the A double dot right angle n, or accumulated value is S double dot right angle n. And A double dot right angle n to S double dot right angle n, that we again just multiply 1 plus I to the nth power. So n is I is the interest rate. So the definition of the annuity, present value of annuity due, the definition of A double dot right angle n is present value of annuity due. So this is equal to, just, that we start with this. So this is worth $1 at time 0, obviously, and this is worth V at time 0, V square at time 0, the V cube at time 0. So this means the 1 plus V square plus V cube plus up to the V to the power n minus 1. So it's even simpler than annuity immediate, and this is just 1 minus Vn over 1 minus V. And so there are several ways to express this. So remember that we have notation D. So V plus D is equal to 1. So D is called discount factor. So we can write this as 1 minus b to the power n d. Yeah, but usually we don't really use the d often, so this isn't very convenient. And actually later I will yeah, sorry. So you don't really have to remember this formula, but the a double dot right angle n is equal to this. So you don't really have to memorize it. You only have to memorize maybe a right angle n double dot. Actually, the double dot is just the 1 plus I times the a right angle n. So I will explain in the next slide. And S double dot right angle n. So this is the accumulated value of annuity due. So this is equal to so this is the 1 plus I times to the nth power times a double dot right angle n. So you can see that the again the v to the power n is 1 plus I to the power negative n. So using this, you can see that this is 1 plus I to the power n minus 1 over d. Yeah, so maybe I mentioned that the d, the v plus d is equal to 1. Maybe d is equal to 1 minus p and 1 minus 1 over 1 plus I, so I over 1 plus I. And properties on, okay, so relationship between a right angle n, a s right angle n, a double dot right angle n, and s double dot right angle n is as follows. So at first, okay, so we think about the time diagram, maybe from 0 to n plus 1. And so we think about the $1 cash flow from 1 to n. $1, $1, $1, $1. Okay. Then what is the present value of this annuity immediate? That is a right angle n. But if we evaluate this at time 1, that becomes a double dot right angle n. Or if we evaluate at time n, this becomes s right angle n. And at n plus 1, this is s double dot right angle n. Okay. So just the relative position is important. So you can see that if an is at time 0 and the $1 is at time 1 to n, so this s right angle n is the present value of annuity immediate. But if we put this as if we put this cash flow at t is equal to 1, this becomes annuity due, because you can see that the relationship between this and this is the same as the previous slide, just shifted by 1 year. So we start at 0 and end at n minus 1 in the last slide, and we evaluate a right double dot right angle n at time 0. But if we shift this by 1 year to the right, then this just becomes 1 to n. So a double dot right angle n is the present, I mean the value of this cash flow at t is equal to 1. And s right angle n is just as is, and the s double dot right angle n, so this is n years after a double dot right angle n. So we can evaluate this cash flow at time n plus 1, that becomes s double dot right angle n. So that means we only have to remember a right angle n. Then a double dot right angle n is just the 1 plus I times a right angle n. And as we studied, if we multiply 1 plus I to the nth power, this becomes s right angle n. And if we multiply the same factor to a double dot right angle n, then this becomes s double dot right angle n. Or we can multiply 1 plus I to s right angle n, then becomes s double dot right angle n. So you basically have to memorize only one of these. Formula for a right angle n. Then others are just we can multiply some factor. Okay, so do you have any questions? Yeah, so now we studied 4 notations: a right angle n, a double dot, s, and s double dot. So in chapter 3, basically everything comes from this a right angle n, but the question becomes more complicated. Yep. Maybe the lecture questions slightly easier, but the quiz questions more difficult. Mm-hmm. Nice. Okay, so yeah, if you don't have a question, we go to an example. Example 1. So you will receive the $300 a year for 10 years, beginning 20 years from now. So the first payment is 20 years from now. Let I is equal to 4%. What is the value of the cash flow at t is equal to 19? Yeah.
It would be 300b plus 300b squared all the way to 300b11 or 300b10.
V10, yes, yeah, you're right. Yeah, that's right. And yeah, and later that we will also calculate the present value itself. But okay, so at first we prepare the time diagram. So always make a time diagram first. For example, if you take a quiz and if you don't really know the answer, but if you write the correct time diagram, at least you will get some partial credits. Okay, so you start receiving $300 20 years from now, and 300, 300, 300, so 10 times. So at first, our objective is to calculate the PV at 19. I would say PV sub 19. Later, that we will calculate this PV itself, but at first we would like to get the PV sub 19, and this is exactly 300 times a right angle 10, because 10 payments, and at time at interest rate 4%. So a right angle 10 at 4%. So this is the 300 times a right angle. So 1 minus 1 plus I to the power negative 10. So 1.04 to the power negative 10. And over I, so 0.04. So you just put numbers in calculator, then you get the 2,433.27. Yep. Maybe I should have asked this PV. But yeah, this. Yeah, so this is the way to go. And with BA2 plus calculator, you can do, where is my BA2 calculator? Yeah, so BA2 calculator, we can use the TVM function, the time value money function. So at first, we clear memory. So the second, and this clear TVM. Second is a gray button, and the clear TVM is, yeah, so the third row, the last column, the most right. Okay, then after that, we enter these numbers at first n. Actually, the order does not matter, but the 10n. So you put 1, 0, then n. N is the third row in the third row. And the interest rate is 4%. So you put the 4 I over y. So don't put 0.04. So we have to put 4. Then I over y. Then 300 as payment. But the 300 is the other side of PV. So we put as
Plus
negative.
minus.
Yeah, plus minus, then payment.
And then compute PV.
Then compute PV, yes. Then you get the 2433.27. Yeah, 300. Yeah, so remember that this cash flow function, all cash flow are on one side of this time diagram. So if you put if you want to put PV and this is $300 for 10 times on the other side of time, the timeline, then we have to put negative sign. If you just put 300, then just PV becomes negative 2,433. Okay, so now that we want to calculate PV, what is PV? So PV is just 19 years before this time point. PV is at 19 years before this time point. So we have to just multiply v to the power 19. So that means the PV is equal to v to the power 19 times the PV sub 19. So 1 plus 1.04 to the power negative 19 times 2433.27. So this becomes 1154.93. So this is the present value. Do you have any questions?
Let me see. Hold on. Okay.
Not really.
100.
I did to the negative 19.
It's a negative 19. So the v is equal to 1 over 1 plus I. So 1 over 1.04. So v to the power 19 is the 1.04 to the negative 19.
Thank you.
Sure.
Clarification, I got confused.
Yeah. So sometimes it's confusing. Just to remember that the v is slightly less than 1. So then you can see that the v to the 90th power is smaller number. Yep. Okay, so that's the example 1. Okay, so example 2. you deposit $100 monthly for 3 years. So basically you deposit $100 for 36 times. And beginning today. So first pay, the deposit is made today. The annual nominal rate compounded monthly is 4.8%. Sometimes annual is omitted. So just the question says the nominal rate compounded monthly. That means the annual nominal rate. So 4.8% is annual rate. And compounded, sometimes it's written as convertible. So nominal rate convertible monthly. So that's the same meaning as compounded monthly. So what is the accumulated amount 5 years from today? And here the strategy is the use the month as the time unit. So usually the payment frequency is equal to time unit is the best way to go. So time unit equal the payment frequency. So here the 1 month. So we need the monthly effective interest rate. J, so this is equal to just 0.048 over 12. So that is the meaning of nominal rate compounded monthly is 4.8%. So this is just 0.004 or 0.4%. So actually this sentence is complicated, but in short, this is 0.4% monthly effectively. So this is J. So yeah, so maybe we also calculate the monthly V. Monthly V is 1 over 1 plus J, so 1.004 negative 1. Okay. Now that we make a time diagram. So 0, 1, 2, 3, and maybe 35. We have 36 payments. So, and starting with today, starting at today. So $100 here, 100, 100, 100, 100, 100. And then this is the last payment. Then 36. Then finally, what is the accumulated amount, the 5 years from today? So that is 60 months from today. So 60. So this is monthly, and the J is equal to 0.4%. Okay, so can you guess the answer? $100, 36 times, and it accumulates. So we want to get this. Oh, you will answer? Maybe 15 seconds more to think about it.
4,270. That's right.
Sorry?
4,270.
You calculated it? Okay, so who said the answer? Sam?
That was me.
Sam.
Yeah.
Okay. Yeah. Yeah, so I think that you calculated the exact number. Okay, so
Sorry, we were
4,000.
supposed to guess.
no, actually probably he calculated the exact number, right? If
Yeah,
you make
sorry,
a guess and that is the 4,270, then I think that's almost, genius in numbers.
I
Okay,
got another
so
answer.
yeah, so this is the answer. Yeah, so
Oh.
the exact answer. So actually, exact answer is 4269, but I think he said that number. Okay, so
$4,269.32.
yeah. Okay, so how to calculate AV, and the idea is that we evaluate this at t is equal to 36. Then after that we multiply some number to get accumulated value. So at this point, the accumulated amount is 100 times the S double dot right angle 36 at 0.4%. Then we multiply maybe 24 months of interest, or you can say, 24 months. So 1.004 to the power 24. So this is the way to calculate AV, accumulated value. So accumulated value is equal to 100 times S double dot 36 at 0.4% times 1.004 to the power 24. Then this is 100 times the S double dot 36. Yeah, so I think that so usually I only memorize the S and A, not double dot. So that we can say that the S double dot is the 1.004 times the S right angle 36. I usually avoid to use the D. So this is equal to this amount. So then S right angle 36 is 1.004 to the power 36 minus 1 over 0.004 and times 1.004 to the power 25 actually. So 25, maybe we should evaluate at 35, then it's a little easier. But anyway, so this becomes the, the 4269.32. So this is the answer. Yeah, and do you have any questions so far? So I memorized A right angle 36 and S right angle 36, but anyway, so those are similar. So maybe you only have to remember one, and yeah, S double dot and A double dot. Probably easiest way is just shift by one term. And how to calculate A double dot and S double dot n in VA2 plus? I think there is a function to shift every cash flow by 1 year. But if you change the mode, you have to go back to the original mode. And I think that it's not recommended, at least for the exam, because you have to be aware of which mode are you using, and that makes some error. So my suggestion is just calculate A right angle n or S right angle n. Then multiply 1 plus I. Or S right angle n is the 1 plus I times S right angle n. Yeah, so in our case, the S right angle 36 Yeah, S is certainly calculated by BA2 plus. So this is actually the 38.638, but this is obtained by the second. Okay, so at first the second clear memory, clear TBM. Then the 36N and 0.4 I over Y. And the $1 payment and plus minus payment. And the compute future value. So here the S, so future value. Yeah, so maybe there are some shortcut. Maybe, you know, we have the 1 plus I here. So you can put, you know, 1 plus I here, then you can immediately get S double dot. But anyway. Yeah, so S double dot 36 right angle 0.4% is equal to the 1.004 times S right angle 36 0.4%. So this is equal to 38.7927. Yeah. Do you have any questions? Actually, lecture is a little faster than the last year.
Professor, so in order to do the second one on the calculator, you would just replace, where would you replace? Oh, okay, I see. Would you replace the 1 by 1 plus
Yeah,
I?
if you replace 1 by 1 plus I, yes, so basically you have to do just the same thing, but the
Okay.
yeah, so then this is the 1 plus 004. Okay, here. Then you directly get 38.7927 directly.
Yeah.
Yeah. Okay, so that we go to the next one if you don't have questions. Okay, so the deferred annuities. So basically we only have this A right angle and S right angle notation, but the we have another way to calculate a deferred annuity. That is, the payment starts later than t is equal to 1. Okay, so we consider the 7 payments starting at t is equal to 3. So that means that we have a $1 payment at 3, 4, 5, 6, 7, 8, 9. So 7 payments. Sorry, maybe we need a little more space. So the one way to calculate this was that we put X here. Then that we calculate PV here. So we basically multiply by V square. So this is one way. So solution 1, yeah. So solution 1 is the PV is equal to V square times X, and X is a right angle 7 at, maybe we need a interest rate. So suppose I is equal to 4%, then 4%. So this is equal to 1.004 to the negative second power times the A right angle. So 1 minus 1.004 negative 7 over 0.004. So you can get this as, maybe I have to ask this.
$23.36.
I don't know, $5 for. Yeah, my calculation $5.549. And another way is a little bit more creative, and we think about the cash flow of $1 9 times. Then we subtract second cash flow of $1 for 2 years. So say this is the first cash flow, and this is the second cash flow, and 1 minus 2 is the present value. So the second solution is the PV is the present value. So present value of 1 minus present value of 2. And the present value of 1 is exactly a right angle n. Sorry, a right angle 9. And the second one is a right angle 2. So we don't have any complications such as multiplying the b square, and it's just a9 minus a2. So this becomes 1 minus b to the 9th power over I minus 1 minus b2 over I. So this is the 1 minus 1.004 to the negative 9th power over 0.004 minus 1.00, sorry, 1.04, 4%. So sorry, everything, the 4%. So 1.04 and 1.04, 0.04. Okay. 0.404. 0. One minus 1.04 to the negative second power and 0.04. And this becomes
$68.35.
Oh, really? I think this is the 5.549. So maybe I can calculate it again. 1.04 to the power negative 9. Okay, and minus 1 and minus divided by 0.04. This is 7 point. Oh, you said the first term? I don't know. 7.4353. And the second term is the 1.04 to the power.
I say what I did.
Yeah, minus 1 and minus and divided by 0.04. This is 1.8.
I got it.
Yeah, 886. So this is about 5.549. So you can do in the same way. So for this specific question, I think the either is fine. Maybe both are easy, but for some questions, the solution too may be faster. especially the more complicated cash flow. It's faster sometimes. Yeah, and we have notation for this, the deferred annuities. So notation is the I don't know how to read it. Two vertical lines, the A right angle 7. Maybe there are some way to call it. So that means the M in general, M bar A right angle N means that A right angle M plus N minus A right angle M. Or we can also say V to the power M A right angle N. So this is basically the solution 2. And this is by solution 1. Yeah, so the N years annuity, but the M years deferred. So either we multiply V to the power M, or that we take the difference between two cash flow. So at first we consider the entire M plus N years of annuity, then we cancel the first M years of annuity. So this is the deferred annuity. Okay. Calculate PV.
So why did we calculate it beginning at 2 when the first payment was at 3?
Sorry, why we start at 3?
Why did we start at 2 when the first payment was at 3?
That's right. But you know that this is basically the annuity immediate, right? So annuity immediate, the present value is evaluated at time 0, but the payment start at 1. So probably that's why that we say this as the 2-year deferred, the annuity immediate. Yes, yeah, that's a good question. Yep. Okay, so maybe we stop here, and the next time that we continue an example of this, and then go to the next section. And the daily quizzes and the homework are already available on the website. And daily quizzes the easiest, and the weekly, homework, it's more difficult. And the exam questions, the past exam questions are a little more difficult than my quizzes. Okay, so that's it for today, and see you next week.
Later. Bye-bye.
Bye-bye.
Bye-bye. See you next week.
See you next week.